Today we're going to be working on 7.1, writing and solving one-step inequalities. This is going to be a two-part video series with part one being over the addition and subtraction properties of inequalities. So the first thing that we need to do is actually to define what the heck is an inequality. So when we break apart the word, we have the prefix in, and then this word equal, and then of course our suffix. So we know that equal is an equal sign. Everybody knows what an equal sign is. But this prefix here and actually means that this is stuff that is not equal to each other. So for example, 2 is not equal to 3. Well, of course they're not equal. Of course we know that. But what if they're not equal, then what are they? What is the relationship between these two numbers? Inequalities, we have 4 options that we can use instead of an equal sign. This is less than, and the way that we can remember less than is it kind of looks like an L. And then we have less than or equal to, and then greater than, and greater than or equal to. In our book, it gives us a table that they want us to fill out so we can kind of work through the addition and subtraction properties of inequalities. So when we look at this first inequality here, we see that it's 2 is greater than or equal to a negative 3. So what happens if we add 3 to both sides? Well, 2 plus 3 is going to give us 5. We have the inequality symbol here is greater than or equal to. And negative 3 plus 3 is going to give us 0. This last column is asking you to evaluate the new inequality here and decide for yourself, is it true or is it not true? Is 5 actually greater than or equal to 0? Well, the answer for that is yes. So we can put true in this box here. Go ahead and work through the next couple inequalities by yourself. I want you to go ahead and pause the video, and then we'll come back together and see what answers we get. So your new inequalities are listed here. Go ahead and take a second to compare notes, see if you have the same answers that I do. Remember, what we do to one side of an inequality, we have to do to the other side. And you want to keep the same symbol for when we're doing addition and subtraction. We're going to use the same symbol that is given in the original inequality. So negative 1 plus a negative 1 is going to give us negative 2. And 6 plus a negative 1 is going to give us 5. Is negative 2 actually less than or equal to 5? Well, yes, it is. So the answer is true. And then we get the same idea for the last inequality. Negative 8 plus a negative 8 gives us negative 16. We'll keep the symbol which is greater than. And negative 10 plus a negative 8 gives us a negative 17. 18, excuse me. Negative 10 plus a negative 8 gives us negative 18. Is negative 16 greater than a negative 18? Yes, it is. The answer is true. Be careful, because if you were to get rid of the negatives on both sides, and if your brain kind of dismisses those, 16 on its own is not greater than 18 by itself. But you have to make sure that you're paying close attention to the negative signs. A negative 16 is less negative than negative 18. And the way that I always like to think about it is debt. If I owe somebody $16, I'm less in debt to them than if I were to owe them $18. So our addition and subtraction properties of inequalities, it basically states that if you add or subtract the same number from both sides of an inequality, you end up with a new inequality that is still true. So at this point, let's go ahead and work through some of the practice problems that they give us in our textbook. This one here that you see on the screen is the same one that's listed on page 204 of your textbook. And it says x plus 5 is less than a negative 12. What the heck does that actually mean, though, in just basic terms? So let's go ahead and draw a number line over here with our negative 12 on this side. Negative 12. So what this is asking us is what number or numbers can x be plus 5 that are going to give us anything less than negative 12. It doesn't want us to equal 12, or excuse me, negative 12, just anything that is less than negative 12. So if this is our plus 5 here, this whole range right here, if this is our plus 5, what numbers can x be that will make this statement still true? So in order to get that, we need to go ahead and solve this inequality. We use the same process as just regular equations that have equal signs. So when we do that, we usually, draw a line down the middle so that we know what we do to one side of the equation, we will do to the other side of the equation. Remember that you do the inverse of whatever is happening. We have to get our variable alone on one side. So x is our variable. We want to get it all by itself. And so we're going to do the inverse of addition because this is saying plus 5. The inverse or opposite of addition is going to be negative 5, subtracting 5. And if we subtract 5 from one side, we have to subtract 5 from the other side. That leaves us with x, which is less than negative 17. We're going ahead and use the same symbol here for the inequality as we were given in our original problem when we do addition and subtraction. So on our number line, remember I said if this was our negative 12, and this is our plus 5 right here, what numbers can x be that when added to 5 are still going to give us less than negative 12? Well, any number that is less than, we said x was going to be less than negative 17, is going to make this statement up here true. So, for example, if you were to plug in a negative 18, if we were to pick that number, plus 5 is less than a negative 12, is this statement true? Is negative 18 plus 5 less than negative 12? Well, negative 18 plus 5 is going to give us negative 13. Is negative 13 less than negative 12? Yes, it is. So the statement is true. So we know that we have the correct range of numbers. Now, be careful if you plug in negative 17, you're going to get x equals negative 12 if you plug negative 17 in right here. But our symbol does not say less than or equal to. Nope, it doesn't. It asks us for anything less than negative 12. So that's why when we're drawing this on our number line, we actually don't use like a closed circle. We use an open circle. That just communicates that we're not including 17. We're just including anything less than the negative 17. So let's go ahead and move on to our next practice problem. And remember, whatever we do to one side of the equation, we must do to the other. What this is asking us on our timeline is if this is our 8 right here, 8 has to be less than or equal to y minus 3. So if these are our y numbers, this is our minus 3. So y minus 3 has to be greater than or equal to 8. So what numbers over here are going to give us a true inequality when we do this? when we solve it. So to solve it, remember we're going to do the inverse. Inverse of subtraction is addition. So we will add 3 to get rid of it on this side and get y all by itself. So if we add 3 to one side, we have to add 3 to the other. And that gives us 11 is less than or equal to y. You could also write it as y is greater than or equal to 11. Sometimes it's easier to think about it that way. Just be careful that you make this a mirror image of itself. You wouldn't want to do y that's less than 11 because that would make these two statements not equal to each other. They wouldn't be true. You would get the wrong answer. So on our number line, we said that 11 is less than or equal to y. Another way of thinking about it is y is going to be greater or equal to 11. So here's our number 11, and this here is our minus 3. And this, of course, is the 8 that we started with. So all of these numbers where this green line is could be numbers that you'd plug into this inequality and the statement would still be true. So you could you could pick 12. So 12 minus 3 is going to give us 9. And is 8 less than or equal to 9? Yes, so that's true. You could go ahead and put in 100. 100 minus 3 is going to give us 97. Is 97 greater than or equal to 8? Yes, so that's true. You could do this all the way up to infinity. So that's how you would solve this inequality. And on our next video, we will go through and work on the multiplication and division.